In our industry, we often say that you should move fast and break things, and that works really well for a lot of applications and a lot of products. But there are some products in which if you make a mistake, then it costs you a lot of money or it causes very serious problems. And this talk will not be about moving fast and breaking things, but it'll be about how you can modernize a product in a very confident way. And please welcome Szymon Fiedler from Arkansas.
Hello. A few months back, our team faced a challenge that many of you might recognize. We needed to implement a new flow that would eventually replace a legacy process, but with three major constraints. First, user experience couldn't be compromised. Any discrepancy between systems would impact customers and potentially create legal issues. Second, cost efficiency meant we had just 3 months to understand, replicate, and improve a complex flow that had evolved organically over years. 30 team members were already working on our customer side. Third, we needed to break from obsolete data while preserving essential business rules embedded in the legacy code base. The obstacles were significant. Documentation was sparse, original developers had moved on, and business rules existed in explicit, implicit, and conditional forms. No single person understood all the rules. Traditional approaches wouldn't work. Full test coverage would take months we didn't have. What we needed was a methodology to systematically identify, isolate, and verify each business rules independently of its implementation. A way to rewrite with confidence. My name is Szymon Fiedler. I'm a software engineer at Arkansas. Today I'm going to share this methodology with you. How to rewrite with confidence by treating existing system behavior as a specification and validating business rules through isolated testing. If you have asked me 3 years ago if InsurTech can be exciting, I would probably laugh a lot, but it can be. There are many definitions of legacy software, but I particularly like this one. Lemonade is the innovative insurance company. They've hit 1 billion in premiums, 10 years from funding. It took other well-established insurance brands 30 to 60 years. Even companies like Microsoft, Netflix, Salesforce, and Tesla, please don't burn my slides, needed more time to achieve that. IT is not the real cost. When we joined Lemonade over 2 years ago to support their mission, the director of engineering, Elad, told us a story about an issue with roof coverage in one of the product lines. They had to hire a legal team to do some 6-month-long sprint to fix things, and this exceeded the overall cost of IT. They used Rails monolith as a foundation, my favorite architecture. There is no coincidence that they had become successful. Since few years, they transformed to microservices architecture. New product lines are released with use of their internal framework, but all the home and renters insurance and more is still handled within our beloved Rails monolith. Insurance is a risk management system where you transfer financial risk to an insurer. You pay small certain cost, called premium, to avoid large uncertain cost, potential loss. It works because risks are spread across many policyholders. It provides financial coverage against specific unexpected events. We couldn't break things. We had to be 100% sure that the new flow provides the same outcome. We had to pick a deliverable scope. Together with Lemonade's team, we agreed that limiting the scope of the work to a single product line within US would be the best approach. This vastly helped us to make this project measurable, deliverable, and in the end, successful. So let's spend some time to explain basic insurance concepts, which we were actually interacting with during this project. HO4 is a type of insurance policy, specifically for renters in the US. It's financial coverage for damages or losses to your staff, legal fees if you're sued by the homeowner, other medical bills if you're at fault, and temporary living expenses if your place becomes uninhabitable. Policy is the legal contract between you and the insurance company. It specifies all the terms, conditions, and details of your coverage. Includes information about premiums, deductibles, coverage limits. Your proof of insurance and reference documents for claims. Coverage defines what your insurance protects against, specifies covered risks, fire, theft, accidents, sets maximum payouts limit, and lists exclusions, means what's not covered. Premium is the amount you pay for the insurance. It's not price, it's premium. It can be monthly, quarterly, or annual. Lower means risk means lower premium. It creates a pool of money used to pay claims. Deductible is what you pay before insurance kicks in. For example, if you file a claim for $5,000 and your deductible is $1,000, you pay the $1,000, the insurer pays $4,000. Lower deductible, higher premium, higher deductible, lower premium. We all love estimates, don't we? Quote is an estimate of your insurance cost. It's based on information you provide. It's valid for a limited time. It's not binding until you pay. And quote becomes policy in the end. Underwriting is about how insurers assess your risk by evaluating the quote. It evaluates factors like property location, protective devices, etc. It determines if you get coverage and at what price. Different companies may do assessment differently. At Lemonade, this process is automated. It relies on external providers and internal processes utilizing data science models. So we had to create quote the modern way and have very same outcome from underwriting process. There was no place for mistakes here. If the proposed premium would be too high, people would resign. Insuring reckless guys like Ricky is a loss for the Lemonade. As simple as that. So how this process used to look like from customer's perspective. The first question is just to check if you have account, because maybe we already know something about you. Select the interesting product, enter your address because we're insuring certain home. Let's select protective devices so our premium can be lowered because they mitigate risk, and some may be mandatory in certain states. Is anybody else need to be covered? And the dog that bites people is not the one we want to offer coverage for, definitely. Okay. What's happening behind the scenes? In fact, a lot of HTTP calls. The quote model is updated constantly with new information. And the following slides will give you an overview of the fraction of the data we had to deal with and decide what's relevant and what's not. As you probably expect, quote owns a column representing its current status. Actually, there are more statuses defined, but some of them are no longer in use or simply are irrelevant in scope of this presentation. The business raised very valid point that they don't want quotes which are pending or stubbed. Pending represents abandoned quote and doesn't bring any value to the system. Stubbed means that we weren't able to make risk assessment due to some third-party issues. This state was meant not to lose customers and show them some stat data, but Lemonade found a better way of doing this. The data model was polluted. There was a whole bunch of logic to filter out those irrelevant quotes at different levels. So it's especially problematic for the data science team. If they wouldn't filter out such quotes, their models would be far away from accurate. During the underwriting process, we wanted to receive a quote which is ready to bind or decline it, nothing in between. This changed a lot. Instead of creating quote at the beginning of the flow and updating it on every step, we will receive all the data gathered by the front-end client, web or mobile, and perform our task at the very end of the flow. We had to decide which data is required and which can be simply dropped. But we had to overcome the unknown. We tried to perform static analysis of the code to figure out which quote attributes and data in serialized columns are necessary to put quote in bindable or underwriting decline status. We quickly figured out that we are unable to do this as there are too many branches in the code. Imagine every state has its own regulations affecting the certain insurance product. Multiply this over product editions. Those are versions which change over time due to legal concerns or business needs. We also share the data model and flow with other product lines. Then we figured out that we can use module prepend and instrument accessors in quote to check which data is involved. This gave us some better overview and the foundation for unit tests of the new feature. But still, the amount of quote attributes was simply overwhelming. But we haven't even touched the HTTP communication, which takes place during the quoting and underwriting. All the first and third party calls allowing us to perform underwriting pick the appropriate coverages, deductible, and premium for the customer. How to ensure that new flow gives the same outcome? Maybe let's write more tests. We weren't able to cover all the possible scenarios, but just a fraction of them. We don't have all the microservices in continuous integration environment. We would need to write stubs for dozens of HTTP endpoints and differentiate their behavior. Mixing this with existing mocks didn't sound doable. So let's make a custom environment which utilizes production data. It would induce a lot of infrastructure work and high cost. We would also run into compliance issues by using production data in non-production environment. Still, we would have to implement comparison mechanisms. So let's test this on production. So, persistence. We needed a place to store quote snapshots. HTTP requests involved to first and third party and a column to store results of our comparison. A simple active record model with a dedicated table was an ideal choice for that. We added two scopes to filter out results which were verified and those who required review. But not every quote is interesting for us. Here is a piece of code we called a round filter. Thanks to Ruby prepend method, we could safely override method run prepare for preview in chat quotes module if the conditions were met. Run prepare for preview is the entry point for underwriting process and what follows: pricing, deductible, coverages. All the terms that we learned at the beginning of this presentation. That's how we infected the code with our sampling mechanism. After initialize hook was used to be sure that all the application code is successfully loaded, and then the game begins. We only wanted to sample data from first-time policy buyers for renter's policy inside US. So quote has to be pending, it has to be renter's quote, and the feature flag had to be enabled. So we initially started looking for 1% of samples, then gradually increased the exposure, but believe me, the scale is so big that 1 or 2% is completely enough. We wanted the data as raw as possible because we didn't want to get tricked by custom attribute readers and typecasting. The HTTP part. Let's look at the recorder. It turned out that TypeUse has a nice callback system which allows to hook when the request is completed. So we can access both request and response details. A perfect match for our use case. That's how we serialized request to persist. The key consists of base URL, params, method, and HTTP method, and body. The value is response code and body. So that's how sample recording look like. Later on, we will use those values to set up stubs. So, okay, that's how it looks all together. So we queried address for given quote. Then we made a snapshot of quote before underwriting started. We started recording all the HTTP requests. Then the actual process is yielded. We assigned recorded request to a variable and release all the HTTP recording. Then we could store 2 snapshots of quote, address and all the requests. We ignored exclusions from Sentry not to miss anything. If something weird happened, you want to get informed. So one more look how it was organized at the top level. Okay. We had to be sure that no background job is scheduled within uncommitted transaction before we could proceed with our idea of testing on production. Since Rails 7.2, this feature is built in, but we weren't there yet. However, one of the greatest things about working at Arkansas is that if you need a solution for a certain problem, it's a great chance that we've already faced it in the past, and the solution lives somewhere. For example, in Rails Event Store, or someone described it like 10 years ago on our blog. 9 years before Rails introduced it, kudos, Robert. So let's make a wrapper which will check if there's a joinable transaction, and we did allow, and it will add our async record mimicking active record behavior. Quack like an active record. When transaction is committed on all the objects inside transaction, transaction records committed is invoked. So there's a collection of all the objects, and each one receives committed method in the end. Okay. The verifier. So let's use snapshot of quote before underwriting process. Use snapshot of quote after underwriting process is completed. Use the same address data. Provide HTTP stubs recorded within our outflow. And compare it with quote after underwriting done in the new flow. Okay. We built quote the modern way using makeQuote method. I won't go into implementation because it doesn't matter and I don't want to expose any critical information. And let's run the underwriting process. The whole thing is wrapped within active record-based transaction. This transaction is rolled back at the end, meaning no trace of additional quote is left in the system. We couldn't pollute the production systems with quotes which are duplicates of real ones. This would break many things like data science models. Due to after commit background job processing, we were sure that no job will be scheduled from our verification flow and no side effects will occur. We couldn't mutate state in other microservices within Lemonade. We couldn't make additional requests to third-party services and break things in external systems, like someone's credit score. Some APIs are expensive, some are slow responding, rate limiting is also a thing. There are 3 HTTP clients used in the application, but we had to care only about 2. FireDie uses NetHTTP, along with some libraries like AWS one. TypeAus is the client of choice for communication with microservices and third-party services. Did you know that TypeAus has built-in stubbing mechanism? Anyone? Okay, so let's block all outgoing HTTP requests. This code effectively blocks all requests performed via TypeAus. We insert callback blocking requests at the very beginning of TypeAus request stack. Then we can yield code we want to execute and remove stubs, so code outside the block has no issues with HTTP communication. Here you can see our with HTTP stubs mechanism applied, along with rollback one. Okay, but we blocked all the traffic. Now let's use all HTTP calls we recorded in the original flow as stubs for the new flow. Okay, sorry. So here you can see we take all the stubs except few we are not interested in. And then we evaluate each key value pair, which is request data and response data. From request we want base URL, and params we want to stub those two and match our stub by those two values and return the original old flow received. So that's how it's tied together. But peace is not always an option. Okay, AWS client uses net HTTP directly. We have found that this as the easiest way to override behavior of the library code, while still being able to download the desired resource from S3, with bold assumption that get is not mutating any resources. It depends, you know. Ruby metaprogramming capabilities shine in cases like that. But there were a lot more specific cases requiring special care. Yeah. But we could experiment safely because all the requests were blocked. The main idea was to separate the samples collection from the verification. This allowed us to do this process asynchronously. If any issues were discovered, we could fix the code of the new flow and run verification again to check if the situation has improved. It's all about gradually polishing the rough edges. So we fed the verifier with the sample and HTTP stubs. Results different than nil from verify method means that there is no misalignment between the new flow and the old one. So it's just a method allowing us to process batches of samples. Nothing fancy here, but it improved our workflow. This is a method for displaying differences between underwriting the code created with the new flow and the old one. So here you can see a piece of a diff. There is wrong status and wrong policy addition we determined in the flow. It also played very well for nested structures, which was crucial for our case. Those are those horror slides from the beginning with all the YAMLs. I'm also a huge YAML fan. Okay, it turned out that there are some attributes that are impossible to compare directly, like IDs, timestamps, which we only had to check in unit tests if those are present and reasonable. So implemented method which is called invariable attributes, where we excluded some of them from the comparison. This dramatically helped with simplifying the code that handles quoting process in the new flow. There is also an ongoing project to abandon a lot of no longer relevant data, and our work was fundamental to make this happen. Yes, we're getting there. So there were two separate processes. We divided collection of sample data from the verification. So let's record the state of quote from the old chat flow before and after the underwriting step. Besides the state, we also recorded all HTTP interactions executed through the underwriting. Let's run the new quote creation flow based on the selected data from snapshots. Use the recorded HTTP calls to stop them for the new flow so we can make sure that there are no side effects when running the validation mechanism. Let's store the discrepancy if there's any. And then let's clean up. We roll back the transaction to clean up the test data and remove all the HTTP stubs. We were able to analyze the differences in behavior without breaking things and easily adapt to it. There were fewer questions asked in new flow. It was simpler in general, with the very same outcome. So this is the part of the message the project leader, Gena, shared across the organization. Please do notice how big in general was this project. And the cooperation with our client was one of the best in my entire career. Here is a little proof that you had the chance to go through the authentic case study. Big shout to my teammates who helped me with this. And yeah, it definitely deserved a conference speech. But there was a panic moment. Gena reached out to me on Friday evening on the day the feature was exposed to a big number of customers. It was a day before mine and his holidays. Both he and I were going for skiing trips with our families. I've jumped on a Zoom call just after a quick cross-check on the backtracker. But he just wanted to thank for one of the best releases he has ever experienced. Both of us could take well-deserved rest. Thank you.
Thank you, Szymon. Any questions?
Hi, thank you. As I understood, you recorded many HTTP requests to different services, and then the new flow was using those recorded requests to do its own logics, right?
Yes.
Why it never happened that you need to send maybe request to a third-party service, but with different parameters or like slightly different request to a third-party service?
I haven't shown this part because I decided that it would be too confusing. We, in fact, evaluated those stubs before passing it. We evaluated those requests, which were stored in the DB, with params matching the new flow. So if we detect, for example, that there's user ID, which has certain pattern, it's public identifier, which is prefix and has certain format, we updated it to our desired format of a new flow. So we were acting like with the data from the new flow, but using stubs from the old flow.
And it never happened that you need to make like a new HTTP request to like another service?
No. The underwriting process itself remained the same, but the whole preparation to it was totally different.
Thank you.
Any other questions?
How long did it took, this whole process?
3 months.
Okay.
With Christmas included.
Thanks for your presentation. So my question is that did this new flow, was this new flow rolled out to production gradually, step by step, or just in one piece?
It was exposed gradually by feature flag, exposed to the bigger amount of users every day.
Of situations when you had to like roll back
No,
disable feature?
there was no such situation in this project to roll back.
Thank you.
Yeah, thanks for the talk. I wonder what other strategies have you considered and which of them you think might also work?
I think that I showed two of them. Like, we didn't find any other viable strategy for that because there are few dozens microservices. So we had like few dozens HTTP interactions recorded in our flow. So I'm afraid we wouldn't be able to do it in a finite time by stubbing everything by hand and all the potential variants, because yeah, I love America, you know, but each state has its own regulations, its own law, and each product has to be different for each state. So it's, yeah, for me it's impossible to do it differently and be sure that you are doing the same. That's gonna be a hard question.
No, it's an easy one. So, I mean, we've all seen this multiple kinds of problems multiple times. Every time I see this, I keep thinking, when will we learn to write a proxy, in this case, a proxy HTTP layer, right? Like, would you agree that if you had gone back in time, you would have made sure that all the HTTP requests go through a class that you own, so you don't need to sort of do this internally?
I would love to, if there wouldn't be like, I don't know, too many flavors of how HTTP clients behave in this project.
Yeah, but
Yeah.
so like what I'm thinking is, does it make sense if someone's building a project now that they think, I know it seems like over-engineering, but it isn't, to make a class that we call HTTP request, and we make sure everything goes through that, even if it just exposes and hides Faraday or something else.
Yeah, I would love this idea, but I think that we wouldn't have enough time for that. And yeah, it's for sure great, how to say that, improvement. Yeah, you propose, yeah, HTTP proxy. The simplest things are sometimes the best, and doesn't come to your mind early enough. But yeah, we chose this way. You know, you sometimes have limited scope of view, and you evaluate some options. Some of them are dumb, some of them are maybe not dumb, but you don't have time to do anything smarter. And yeah, that's how it went, I believe.
Hey, Szymon.
Hello, Adam.
So my question is how tough it was to convince clients to agree on that, considering that he probably was aware how risky it would be if you fuck up?
I didn't understand part of your question. Everything we're
So
laughing.
my question was, it was just like client was believing in you so much that he doesn't have a problem with that?
Yes,
Okay.
yes, our relation is over 2 years. And
Okay, and if
they had-
it wasn't be like that, how you would try to convince him that there is no other way to do it properly than that approach? Like, I mean, testing on production.
I
basically.
think that, you know, speaking in the best possible language, which is money, how much it would cost doing it differently.
Any other?
Yeah.
Silly question. Were all those dynamic changes thread safe?
Yes, hopefully yes, yes, yes.
Because you were using Unicorn, or why?
Unicorn.
Got it.
Yeah. Yes. Yeah, there's. Yeah, I can say that we. Yeah, I had the slide, but I removed it because it was too abstract. Yeah, we have concurrent Ruby in the project, and we use concurrent async objects. But we did nasty little trick to make them inline, so we were sure that that they will happen in our block within our process, and nothing will go anywhere. Yeah. Thanks for this question.
Okay, we got time for one more. All right, thank you for your questions. Thank you, Szymon,
Thank
for
you.
presentation.